Hey guys, welcome back to Eureka, and in this video we're going to be doing a revision for the periodic on week 3 for pure math. We're going to start with the revision sheet and we're going to do the questions in order. So let's start. Page 22a. They're telling you they want the combination of n plus 2 from 3. So we know in general that the combination nj is just m factorial over j factorial multiplied by n minus j factorial. This has been explained in a different video. So all we're going to do is just substitute into the formula. In this video, by the way, it's going to be quite dry, like the explanation, because I'm not going to explain anything. It's just a solving video. I already explained this in a different video. Combinations, binomial theorem, so on and so forth. Right, so we get this. Now we need to simplify this. So let's simplify n plus 2 factorial. This is just n plus 2 multiplied by n plus 1 multiplied by n factorial, right? That's the definition of n plus 2 factorial. If you want, you can expand it out and you'll figure it out by yourself. N minus 1 factorial is n factorial over n. Why is that? So I'll tell you why. N factorial is just equal to this, right? Until you reach 1 over n, right? So n cancels with n. You're left with this, and this is just n minus 1 factorial. Good enough? Oh, my breathing's quite heavy. I was running for fun. So let's just substitute into the formula. N plus 2 factorial is just n plus 2 multiplied by n plus 1 multiplied by n factorial. And multiplied by 6, n factorial over n, right? Let's multiply by n in the numerator and denominator. We get this. Yes, we get this. And yeah, we get this. So n factorial cancels with n factorial. All you're left with is n plus 2 multiplied by n plus 1 multiplied by n over 6. Let's go to B. B tells you they want the combination of n plus 1 from n minus 1. This is just equal to n plus 1 factorial over n minus 1 factorial multiplied by n minus 1 minus n plus 1 factorial, right? This is just equal to n plus 1 factorial over n minus 1 factorial multiplied by 2 factorial, right? N minus 1 minus n plus 1 is just 2. And we're just going to substitute. N plus 1 factorial is n plus 1 multiplied by n factorial. N minus 1 factorial is n factorial over n. And 2 factorial is 2. Multiply numerator and denominator by n. You get this. Okay, and then just cross out n factorial. You're going to get n plus 1 multiplied by n over 2. Right? So let's go to number 3. I'm being a bit quick with this because this is just combinations, so it shouldn't take that long. N factorial over r factorial multiplied by n minus r factorial by definition. B is combination n from 0. N factorial over 0 factorial multiplied by n minus 0 factorial. The factorial is outside the parentheses. That was just a mistake. There we go. 0 factorial is 1. So yeah. This is 1. And this is just n factorial. Then they cancel out, you get a 1. That means any variable combination 0 is always equal to 1. Good enough? Okay. Now let's move on to the sigma chapter since we're done with combinations. That didn't take that long because we already explained it in a different video. So here we go. Sigma. We have on page 22 activity number 1. Number 2a is coming if you check the revision sheet. So sigma I goes from 1 to 6, 2i minus 1, right? We can split the sigma into this. We already taught this in a different video as well, so feel free to go watch it. We can split this into 2 sigma I goes from 1 to 6 of I. We remove the constant of 1. This is equal to 6, and you bring down the minus. And this is just equal to 2 multiplied by 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? This is 42 using a calculator. Minus 6, you get 36. Good enough? Let's go to D. Number 2D. That's also coming in the revision sheet. Sigma k goes from 1 to 5. 5k multiplied by k plus 1. Let's simplify the inner term. So we're going to get 5k squared plus 5k, right? We just distributed. And we can split sigma. As I said, I already taught in a different video how you can split sigmas of 5k, right? Here we can factor out a 5. We can keep the sigma. Same with this, we can factor out a 5. We can keep the sigma. And this is just equal to 5 multiplied by 1 plus 2 plus 3 plus 4 plus 5. And this is equal to 5 multiplied by 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. And you bring the plus down. Now using a calculator you can evaluate this and evaluate this. So let's use a calculator. Yeah. Alrighty then. Alright. The answer is 350, most probably. You can use a calculator to figure it out. Now let's move on to the next activity, which is activity number 2, page 23. Sigma of m goes from 1 to 10. M squared plus 2m plus 1. Let's split the sigma into this, right? This is the sigma property. Already taught in a different video. I'm just going to keep repeating that statement because I am a big idiot. Now this is equal to 10, right? The constant multiple rule, 1 times 10 is 10. This is just equal to 2 multiplied by 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. And this is equal to 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared plus 8 squared plus 9 squared plus 10 squared, right? So you need to do this term plus this term plus this term. So all you have to do is just use a calculator. And yes. So this is equal to 110. And this is 10, goes down. And then we're going to have to simplify this. So this is just equal to, again, let's use a calculator. Remember guys, calculators with sigma are not allowed in the exam hall, I believe. So good luck. This is equal to 385. And you can do simple arithmetic. And the answer is supposed to be 505. Okay, now we move on to the hard part. The binomial theorem. Page 24, and here we go. We're just going to solve the activity. A plus b, all raised to the power of 6. They're telling you expand. Now we're going to expand using the Pascal's triangle because that's the easiest way to expand. I already taught the Pascal's triangle in a different video. It's called the Binomial Theorem video. So, yeah, I'm just going to write down the method. Right, if you have 6 as an exponent, then you list down seven terms, right? 1, 2, 3, 4, 5, 6, 7. And then you start from the highest power of a. 1, 0. And then b goes in ascending order. Am I right? And now, all we're missing are the coefficients. So how are we going to figure out the coefficients? That's pretty simple. We just draw the Pascal's triangle. Again, we already taught this in a different video, so there is no need to be afraid. All of this is taught in a different video. 4, 1. And now we reached the power of 6. So this is 0, 1, 2, 3, 4, 5, and 6. These are what we want. 1, 6, 15, 20, 15, 6, 1, right? 1, 6, 15, 20, sorry about that, and 15, 6, 1. This is your answer, and it didn't take 3 minutes to solve. Instead of using the binomial theorem, which is sigma k goes from 0 to n, so on and so forth, you really don't have time to do that in the exam, so just use the Pascal's method. And let's go to the next activity. Alright, so here we go. Activity number 2, page 25. We have question 2, 3, 4, and 5 coming included into the periodic. So let's start with question 2. They're telling you have 3x plus 1 over 3 raised to the power of 9, right? Well, they're telling you give us the term that has x squared in it. Let's just write that down. Not x squared, really sorry, x to the power of 5. So there's some coefficient and there's x to the power of 5. That means the only x term, which is 3x, should be raised to some power, which is n minus k, according to the binomial theorem. K goes from 0 to n combination k, 3x is raised to the power of n minus k, 1 over 3 is raised to the power of k, right? This is supposed to give you 3x raised to the power of 5, right? Because this will give you 3 to the power of 5 multiplied by x to the power of 5, and this is what we want. So that just means that n minus k is supposed to be equal to 5. N is given in the question, n is just the exponent, which is 9. So in this case, k equals 4. Simple mathematics, right? So now, all we're going to substitute, so we know that k is 4, all we're going to substitute is 4 into k, and we're going to find the expression. Of course, we're not going to be using the binomial expansion, like the whole binomial expansion, because they only want us to find the term that has x to the power of 5. They never said expand everything, you know? 3x multiplied by 9, 3x raised to the power of 9 minus 4, 1 over 3 raised to the power of 4. Using a calculator, 9 combination 4 is just 126. 3 raised to the power of 5 is just, bear in mind I'm just simplifying here, yeah? So there's no need to panic. Multiplied by x to the power of 5. And 3 raised to the power of 4 is just 1 over 81 here. Now, using a calculator, you can simplify this. You're going to get 378 x to the power of 5. This is an 8. That should be your answer. Now we're going to be doing question number 3. We're going to go in order, as I said. Question number 3 tells you write the sixth term of 1 plus, so question number 3, 1 plus 2x raised to the power of 9, right? They want the sixth term. Sixth term does not mean x raised to the power of 6. It just means that give us the sixth term actually. So in the binomial expansion, you're going to have something like this. n0, n1, n2. I'm not going to write down the binomial theorem. I'm just going to write down the combinations because there's no difference until you reach n to the 9, right? But then they just want the sixth option. So 1, 2, 3, 4, 5, 6. This is what they want. They want k to be equal to 5. That just means if they tell you they want the 7th term, then k is equal to 6. If they tell you they want the 100th term, then k is equal to 99. You just subtract by 1. Good enough? So all we're going to do is substitute into the binomial theorem. And of course, we're not trying to expand. We're just trying to find the numbers. So it's going to be 9 from 5. 1 raised to the power of 9 minus 5. 2x raised to the power of 5, right? Now, 1 raised to any power is equal to 1. So we can remove this, except for infinity. 1 raised to infinity is something else, but that just came out of nowhere. Really sorry. I love infinity, guys. I love infinity. Anyways, let's just evaluate. 9 combination 5 is 126. And 2x raised to the power of 5 is 32x to the power of 5. And now the answer is just 4032 x to the power of 5. If I'm not mistaken. Let's see. Yes, it is. That is your answer. Let's go to question number 4. And if I'm going too fast, guys, well, tough luck. Sorry. Just needed to show some stupidity off. So now you have number 4. They're telling you obtain and simplify the coefficient of the term in x squared, right? And you have 2x plus 1 over 2x raised to the power of 8. They're telling you they want the expression that has x squared, right? So how are we going to find that? So in the binomial theorem, we know that binomial theorem is like this. 2x raised to the power of n minus k. 1 over 2x raised to the power of k, right? Now we need this to multiply by itself, like we need these two to multiply such that you get some coefficient and x squared, right? That means 2x raised to the power of n minus k multiplied by 1 over 2x should be equal to some coefficient multiplied by x squared. So I'm just going to rewrite this expression. How am I going to do that? So 1 over 2x raised to the power of k is the same thing as saying 2x raised to the power of minus k, right? This is just simple math. So let's rewrite this. It's going to be 2x multiplied by n minus k multiplied by 2x raised to the power of minus k. And we can further simplify this into 2x is raised to the power of n minus 2k, right? So 2x raised to the power of n minus 2k is supposed to give you some number multiplied by x squared. How are we going to get x squared here? Well, the coefficient here must be equal to 2, right? Because 2x raised to the power of 2 is just 4x squared. And this is what we want, which is x squared. So let's just erase some of this garbage. We need n minus 2k to be equal to 2, right? We know that n is 8. It's given in the question. That's the exponent. And we can simplify. 4 minus k is 2. K equals to 2. Sorry. What the hell did I just do? We divide by 2. Yeah, this is equal to 1. I'm really sorry about that. That's just me being stupid. K is equal to 3, right? There we go. We found k. So all we're going to do is we're going to use the binomial coefficient and we're going to simplify. So k is equal to 3. So yeah, here we go. So we can substitute n and k. N is 8, k is 3. N is 8, k is 3. Alright, and here k is 3. And of course we're going to ignore the sigma because we only want one term, right? So let's simplify this. 8 combination 3 on the calculator is equal to 56. Right, this is 56. 2x raised to the power of 8 minus 3 is 2x raised to the power of 5. So let me just evaluate that. That's just 32x to the power of 5. And 1 over 2x raised to the power of 3 is just 1 over 8x cubed. Now this simplifies into, 1 second. Um, 224 x squared. And this is what we want. We want the term that has x squared in it, so the coefficient is 224. Let's move on to the final question in this chapter before we move on to the Pascal's triangle chapter, or Pascal's triangle section. I'm very dyslexic today, so yeah. So number 5, they're telling you you have x minus 1 over x raised to the power of 10. They're telling you they want the term that has the coefficient 1 over x to the power of 2, right? We're going to do the same method. 1 second, let me just scroll. We're going to do the same method. Let me write this on a different page actually, so you guys can feel like you're renewed. And yeah, so we have number 5, x minus 1 over x raised to the power of 10. And they want the term that has 1 over x squared. By the way, 1 over x squared is just x to the power of minus 2, right? When you have a fraction, just try to simplify it down to one term instead of a whole fraction, because that just makes it better for you. So the binomial theorem tells us k goes from 0 to n. N combination k, this is an n, x raised to the power of n minus k, 1 over x raised to the power of k, right? Well, here, they want the term x to the power of minus 2. So they want this to simplify to something which is equal to x to the power of minus 2. 1 over x raised to the power of k is the same thing as saying x raised to the power of minus k. I already showed you why. It's like this. Look, 1 over x is equal to x to the power of minus 1, right? You probably know this. This is just simple mathematics. And yeah, well, yeah, I have nothing else to say. It's simple math. So let's simplify this. It's going to be x to the power of n minus 2k. And this is supposed to be equal to x to the power of minus 2. That means n minus 2k is equal to minus 2. N is given in the question to be 10. So let's substitute n. And let's just find out k. K is 6, right? Substitute 6. You get 10 minus 12, which is minus 2. So all we're going to do is, since we found k to be 6, we're just going to substitute k into the equation. Of course, we don't need sigma. We don't need this sigma. We just need this because they want one expression. Okay, we're just going to substitute. Right? Now, 10 combination 6, you can use a calculator. That's 210. X raised to the power of 10 minus 6, which is x raised to the power of 4. And 1 over x raised to the power of 6, right? This just simplifies to 210 over x squared. And that is your answer. Now we're done with the binomial theorem chapter. Let's move on to Pascal's triangle. Alright, so let's go to a new page. Let's clear everything. And here we go. Pascal's triangle chapter. We only have 2 questions. So open the book on page 28. They're telling you, number 1. You have 3x minus 1 over 3x raised to the power of 8. They're telling you find the constant term. So let's just write the binomial theorem down. K goes from 0 to n. N combination k. 3x raised to the power of n minus k. And 1 over 3x raised to the power of k. 1 over 3x raised to the power of k is just 3x raised to the power of minus k. I already showed you how. So let's just rewrite all of this into just 3x raised to the power of n minus 2k, right? Simple math. Now, what we're trying to do is to find the constant term. What does constant term mean? It means that we don't have a variable. Now, we need this to be equal to some number that does not have a variable, no variable. Right? How do we get no variable when you're raising something to an exponential to an exponent? So let's say 4x. 4x raised to what number will give you one number with no variable. No variable, right? Well, the only exponent is 0 because 4x raised to the power of 0, and this is just an example. 4x raised to the power of 0 is 1, right? So this is exactly what we're trying to do. We're trying to get rid of the x. How are we going to do that? Well, n minus 2k is going to be equal to 0. And n is equal to 8, given in the question. So what is k? K is equal to 4. Because, yeah, 2k equals 8. And then simple math. K equals 4. So now we're just going to substitute k in here. And we're going to substitute n. And of course, we don't need the sigma. Because we want one term, we don't want an expansion. No expansion. Here we go. So k equals 4. So k equals 4. We're just going to substitute everything back. N is equal to 8 and k is 4, right? So 8 and 4. 8 minus 8, right? Well, this is equal to 1. And all we're left with is 8 combination 4. And we can use a calculator to figure that out. It's 70. And that should be your answer, which is 70. So, yes, let's go. By the way, if you notice something, at the beginning of this question, I wrote sigma like this. K goes from 0 to n. N combination k. 3x raised to the power of n minus k, 1 over 3x raised to the power of k, right? I forgot to add the negative, right? But in this question, it doesn't really matter if you have the negative or not, because we're working with even powers. We had the combination 8 from 4. That's a mistake on my part. I'm sorry about that, but yeah, in this question it doesn't really matter. So next time just add the negative, but the answer shouldn't change if you're working with the even exponents, you know? So let's look at number 2. They're telling you you have 2.02 raised to the power of 10. They're telling you give it the two decimal places. Right, so we're going to use the binomial theorem expansion to get it to 2 decimal places. So 2.02 can be rewritten as 2 plus 0.02, and we're going to raise it to the power of 10. Now you know what to do. We're not going to use the binomial theorem to expand all of this because it's going to be boring and it takes way too long. So we're going to use the Pascal's triangle method. We said if we have an exponent of 10, then we're going to have 11 parts. So 11 terms. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Well, now we only need to put the exponents and the coefficients. So we said we go in descending order first. 6, 5, 4, 3, 2, 1, and 0. You can obviously use the binomial theorem to expand this, but there's really no point. It takes way too long. And we said we go in ascending order here. So 3, 4, 5, 6, 7, 8, 9, 10. There we go. So all we're missing are the coefficients, which are supposed to be here. And then we're going to add them all up, right? There's a plus here, 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 and plus here, right? If this was a negative, then all of these would be negative numbers. Well, not all of them. If it's raised to the power of, 2, then it's probably going to be positive. But don't worry about that for now. There's no negative, so yeah. What we're trying to find are the coefficients now. How can we find the coefficients? Well, we can simply use Pascal's triangle. So I'm going to draw the triangle on a new page. We're gonna come back to this page. But I need you to memorize the exponent. The exponent is 10. So we need to find all the coefficients of the 10th exponent. So we're going to start with 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20. By the way, as I'm writing this down, you can kind of realize a pattern in the numbers. You don't really need to know this pattern. It's not that important. I'm going to be stopping at some parts here because I'm going to be using a calculator to evaluate some of these numbers when they get too big. But you can kind of notice a pattern, right? What's 35 plus 21? Ha! 21. Ha! That's 56. That's 70. 56. 28, 8, 1, 1, 9, 36, let's see, 84, 126, 84, sorry, 126 here again, 84, 36, 9 and 1, and finally 110. Yeah, let's just use a calculator. Actually, we don't need to use a calculator. This is just the multiplication table. 120. Yes, and 126 plus 84 You can obviously use the binomial theorem to expand, but that takes way too long, as I said. It takes longer than this, I promise. So we're just going to do it using the Pascal's method. So 120, so on. 100, and I'm just going to rewrite all of this in a better fashion, right? So 1 goes here, 10 goes here, 45 goes here. 84 plus 36 is 120. 126 plus 84 is 210. 126 plus 126 is just 252. 126 and 84 is 120. 84 and 36 is just 45. Sorry, 84 and 36 is not 45. I'm being stupid at math right now, guys, forgive me. To be honest, I've been trying to record this video for the past, I don't know how many days. It's not, I don't have enough space, guys. I don't have enough space. I'm sorry. So let's just extend this here. This is 10. This is 45. This is 36 plus 84. 120. This is 126 plus 84, which is 210. This is 252. I have 84 plus 126, which is 210. We have 84 and 36, which is 120. Then we have 45. Then we have 10. Then we have 1, right? So our coefficients are 1, 10, 45, 120, 210, 252. And then if you guys can see the pattern, then we're just going to repeat the numbers. 1. Can you see the pattern? This gets repeated here, this gets repeated here. But anyways, you don't really need to notice it. So just memorize it. 110, 45, 120. So 110, 45, 120. Let's go back. We're going to add them here, right? So 1, 10, and let's continue. 45. We're going to multiply here by 120. And then I believe 210. Let's just be like this. 210. 200 and let's see. So 252. 252. And then it goes in descending order, right? So 210, 120, 45, so on and so forth. 210 multiplied by, I don't know, I know this is quite confusing for you guys because I'm moving the screen like a lot. Sorry, this is not 210, this is 210. So let's just go back. 120, 45, 10, 1. 45, 10, and 1, right? And well, you can use a calculator to figure all of this out, and that would be faster than using the actual binomial theorem. And yeah, now we're gonna have one section left, which is section 2.2.4, I believe, but I'm gonna do that in a different video. So thanks for watching.